Here we have some acceleration problems. The most important part of doing acceleration problems is knowing the definition of acceleration. That is, acceleration A equals change in velocity over time. In our first problem, a car starts from rest and accelerates to a velocity of 45 meters per second in 5 seconds. So first thing we need to find is the change of velocity. It starts from rest, which is 0, and reaches 45 meters per second. So that is our change in velocity over 5 seconds. So that is 9 meters per second. 3 seconds after the car started moving, you simply take your acceleration times the time, you get 27 meters per second. And number 2, a train is traveling 40 kilometers per hour. What is the acceleration rate if it accelerates to 60 kilometers per hour in 3 seconds? So we find first the change in velocity. It starts at 40, goes to 60, which means it added 20 kilometers per hour. It did that in 3 seconds. So you get 6.67 kilometers per hour per second. In B, we're asked to find what the acceleration rate of the same train is when it slams on the brake and comes to a stop in 12 seconds. The first thing you should notice is that it says comes to a stop. When it's stopped, the velocity is 0. So once again, we're going to start with our velocity 60, goes to 0. That means its change in velocity was negative 60. It started at a positive 60, slowed down to 0. And then once again, we're going to divide that change in velocity by the time. Get our units. We'll get negative 5 kilometers per hour per second. In number 3, a runner starts from rest and accelerates uniformly, which means there's a single acceleration, only one value, like all of the problems before, for 6 seconds until she reaches a top velocity of 9 meters per second. So here, once again, she starts from rest, which is 0, and accelerates to 9 meters per second. That's a change in velocity of 9 meters per second, and she does this in 6 seconds. Therefore, her acceleration rate is 1.5 meters per second per second. Now we're asked to find how far she traveled before she reached this top velocity. The way we're going to do that is we are going to take her average velocity, which between 0 and 9 seconds, her average velocity